So that's just an assembly language idea. So writing an assembly language program that does the same thing as this Python program here. So the only thing that direction we've got is we need to store the result back to memory address 1000. So this is not necessarily the kind of thing that you would get in the exam. The A-level exam is not just based on Python. They might give you some pseudocode that does the same kind of arrangement. So we can obviously use some registers in the processor. That's what we're going to do. So we'll start off with a move, and we'll move to R0, the value 0, and that's just as setting up the idea of total being 0, and we'll just keep a track of our registers on this side as well. So then we want to set up R1. This is going to be our counter, so I, this is going to be, so it's starting from 0, so we're going to set that counter up as 0, R1, and we'll just put that there so we can keep a track of what we're doing. So then we're going to need to loop this program. So we're going to have a label called start loop. You can call those labels anything, so I'm just calling it start loop for this idea. So the next thing I'm going to do is add, and I'm going to add R0 to itself to R1. R1 is where we're keeping I there. So at the moment I is nothing. So if we start off and think about it, then we made R0 0 here, we made R1 0 here, and we've added 0 to 0. So we've essentially got 0. If we want to put it in again, we could do. It's not changed. So the next thing to do is we want to do a compare. So we're comparing R1 because that's our counter. And we're going to compare it to. No, actually, we could do that there, but let's actually first of all let's increment our counter. So we could add R1, and we'll just add 1 to it. So that's like it's just doing the loop there. So then we'll compare. Now we've done it. We'll compare R1 to 5 because 5's our top end there. And if it's not the same, so we want to branch if it's not equal to. Because if it is equal to 5, we're going to stop. But if it's not, then we go back to start loop. And then if we've not gone back to start loop, then we'll have finished. So we can store the value of our total, which is R0, into memory address 1000, because that's what it asks us to do up here. And we can halt the program because we've sort of finished. So we can think about tracing this idea. So when we're going to add 1 to R1, compare R1 to 5. Well, it's not 5 yet, so we're going to go back to our start loop up there and add R0, R0, R1, so R0 becomes 1. Add 1 to R1 becomes 2. Compare, well, it's not 5 yet, back to the start. Add R0, R0, R1, so we're going to add 2 and 1 now to make it 3. Add 1 here. It's still not 5, so we'll carry on. So we're going to add 3 and 3 next. It'll be 6. This one will become 4. It's still not 5, so we'll just put a little X there to remind us. Then 6 and 4 added together is 10. This becomes 5, and now it is 5. So it's equal to that. So now we'll store the value R0. And if you write this program, simple program, and you run it in Python, it will come out with the value 10. So we've done our program in assembly language.